بسم الله الرحمن الرحيم. في الميتنج اللي فات, في the last meeting we discussed the future value and the application in finance. However, there are some applications in other areas in finance. We can apply the future value. For instance, we can estimate the growth rates of sales, for instance, and what is the future sales, for instance, after 10 years, if we consider the growth rate is 7%. So this example here is like applications in other areas in finance. A DVD rental firm is currently renting 8,000 DVDs per year. Okay? How many DVDs will the firm be renting in 10 years if the demand for DVD rentals is expected to increase by 7% per year? So now the current selling is 8,000. This is expected to grow by 7%. The question is, what is the future DVD demand, after 10 years? So we can apply the same concept. The same concept is the future value is equal to the present value 1 plus I power n. So we have the present value is 8,000. 1 plus I, let's consider the growth rates in this case, is the growth rates. So the growth rate is 7%, or 7, power of 10. Yeah, do the calculations. So if you have like this calculator, please use it.
15,000.
So we have 8,000 1.07 power 10. So it is 15,737 DVD. So the answer is 15,737 DVD. Okay? You know how to use the calculator, okay? No? Yes? Okay, so another example is your annual tuition at a state university is currently $20,000. The current one. If the tuition increases by 6% annually, what will be the annual cost of attending the state university in 25 years? So it means it is now $20,000, but after 25 years, you don't know how much it costs. And the state university has a policy to increase the tuition fees by 6% a year. So calculate how much you will pay in the future. Okay, the same concept.
Yeah.
So 20,000. So the future value, 20,000. This is the present value now.
Yeah.
And 1 plus I is the growth rate, 6% over 25 years. Try to do it. Use your calculator, please. Okay, I will do the same. 20,000, 1 plus 06 power 25. So the result is 85,837. Look at the amount. Now we can pay $20,000, but after 25 years we will pay $83,700. So it's big amount. So you have to invest in this. We will do it. Okay, just be patient. Okay, so now compound interest with shorter compounding periods. For instance, now the majority of banks calculate interest based on the annual interest. Other banks or other financial institutions, they calculate based on the, for instance, semi-annual, twice a year, or quarterly 4 times a year, or daily
Monthly.
360 times a year, or weekly around 52 times a year, or monthly 12 times a year. So it means the interest is compounded every day, for instance, or compounded every month. So this is what it means, compounded interest with the shorter compounding periods. So banks frequently offer saving account that compound interest every day, month, or quarter. So what do you think? If the bank suggests you to calculate the interest on the daily basis or on the annual basis, which you prefer, the annual basis or the daily basis? Annual. So, annual. Okay, so keep this question in your mind. Remember that you said annual. Okay, just remember this. We will see whether you are right or wrong. Again, the question is, if the bank suggests you to compound the interest annual or daily, so you said annual. Okay. Listen here now. More frequent compounding will generate higher interest income for the savers if the annual percent rate is the same. So again, more frequent compounding will generate higher interest income for the savers if the EPR is the same. For the more the bank compounded the interest, the more income you generate. So you are not right.
Yeah.
The more the bank compounded the interest, the more income you can get from the bank. So we prefer daily rather annual. We will see this on the calculations. See this example here. You invest $500 for 7 years to earn an annual interest rate of 8%, and the investment is compounded semi-annually. So how many times a year? Two. Two times. Okay, just go back to the equation here. Future value is equal to the present value times 1 plus I times n. This is the standard equation. Now, the future value, if we are compounded in different formats, so the future value is equal to the present value times 1 plus I divided by the number of times that we compounded times n times by the number of times that we compounded.
Yeah.
For instance, if we compounded it semi-annually, so we compounded it 2 times. So the present value is equal 1 plus I divided 2 by n times 2. If we compounded this, so this is compounded the future value semi-annually. If we compounded this quarterly, if we compound this quarterly, future value is equal to the present value. Now this is a quarterly, careful. This is future value for semi-annual. So if we compound this as quarterly, so the present value times 1 plus I, so I is divided by 4, and n is multiplied by 4. Okay? So now, try to do this example here. You invest $500 for 7 years, so you know n is 7 years, to earn an annual interest rate of 8%, and the investment is compounded semi-annually. What will be the future value of this investment? Okay, how you do this? Okay, let's the rest of the students. كل الطلاب بدي اشوف ان هم where is your calculator? What is it? You don't have. Okay, next time please bring your calculator with you. Okay? So do it now, which is much better do it the day after tomorrow. Okay, so to sort this out, so the present value is $500. 1 plus I is 8%. 8% divided by 4, divided by semi-annual, this 2. And 7 days times by 2. And using the calculator as well, 500 times 1 plus 0.8 divided 2 power 14. So it is 865.83. All the students using the calculators? No? Yes? Yes. Okay. So we'll see the answers. 865. As we observe, 500, 8% divided by 2, 7 multiplied by 2, and we have the answer. And look at this table here. If you observe, this is the interest rate, 2%, 5%, 10%, and 15%. This is compounded annually. If you look at the first row, so the more interest that we apply, the higher interest that we apply, the higher income that we generate. Look at the first row.
Yeah.
Okay, other things are equal. So it's compounding annually. But look at the second row. If we compounded it semi-annual, look at the first one, it is 102 plus 0 or 1. So if we compound it quarterly, it's increased, and so on. If you look at the 5%, it is the same things. For 10 years, this is for 10 years, we are using, this is for 1 year. For 10 years, we are using 100, 2%, 121, then 122, and then. What you observe in this? What you observe? In the compounding quarterly, monthly, weekly, and daily.
It's nearly the same.
Yes, what you observe in the weekly and daily. You can compound this, and after a period of time, it is you generate the same income. It doesn't matter how many times you generate it. For instance, it doesn't matter you compound it as quarterly or monthly or weekly. So it is the same. It generates the same thing. But okay. This calculate future values using non-annual compounding. Try this question. You have been put in charge of managing your firm's cash position and noticed that the Plaza National Bank of Portland has recently decided to begin paying interest compounded semi-annually. So we know this is 2 times. Instead of annually, if you deposit $1,000 with the Plaza National Bank at an interest rate of 12%, what will your account balance be in 5 years? So we know the future value. So we know the present value is $1,000, and we know the number of years is 5 years, and we know I is 12% and is compounded semi-annual. It means 2 times. So now the answer is 1,000 times 1 plus 12% divided by 2 times 5 times
2.
2.
1,790.
And you will see the answer is 1,000 times 1 plus 0.12 divided 2. Okay, power 10. So the answer is 1,790. Okay, so 1,790. 1,790.84. Okay, so we'll see the answer here as well. 1,790. Okay, the second one, or the third, if you deposit $50,000 in an account that pays an annual interest rate of 10% compounded monthly, what will your account balance be in 10 years?
Divided by 12.
12 ضرب 12.
Yeah, do it. Huh? Try with yours. So again here, it is 15,000. 1 plus I is 10% divided by 12, because 12 times, and 12 times 10.
135,000.
So the answer is 50,000. 1 plus 10% divided by 12 power 120. So the answer is 135,352. Okay, so the answer is 135,352.07. So this is the answer. Okay? Fine. The same. Now, discounting and the present value. We talk about the future value. What is the future value of the present value? Now, we will talk about what is the present value of the future value. It means if we expect to receive money after 10 years, what is the present value today? Okay? So, it is the same things, just do the equations in this way. The future value is equal to the present value, 1 plus I power n. Then the present value is equal future value divided by 1 plus I power n. Okay? This is by using the scientific calculator. You can use this. Okay? Let's see. Take this example here. How much will $5,000 to be received in 10 years to be worth today if the interest is 7%? So now, the present value is 5,000. Is it right?
No.
Yes, it is wrong. This is the future value. So the future value is 5,000. How much will 5,000 to be received in 10 years? This is future value. And I is 7%. And N is 10 years. We have to calculate the present value. So the present value is equal to the future value divided 1 plus I power n. So the future value is 5,000 divided by 1 plus 7% power 10. Okay? So do the calculations again. 5,000 divided 1.07 power 10. So the answer is 2,541. Okay. See. Impact of interest rate on the present value. look back to the future value and the present value. The present value. The present value is a function of I and n, but it is opposite function or inverse function. It means if I increases, the present value decrease. If n decreases, the present value increase. So if n increase, the present value decrease. If I increase, the present value is decrease. So again, we are using here 7% as a discount rate. If we are using 9%, what do you expect the present value to go up or to go down? Down. To decrease. If we are using 12%, it's go down. If it is 0, if it is 0, no change. So if it is no change, what it means? Exactly. The present value is equal to the future value. If this 0, it means the present value is equal to the future value. If it is 1%, it's little decrease. If 2% more decrease, then and so on. Okay? And the more years we are using, the more decrease in the present value. For instance, if we are using 0 here, yes, so it means the present value is equal to the future value. Now, if you are using 1, it's decreased little bit. Then if you are using 2, it's decreased more and more. Okay, let's see the examples and the equations. Let's try to apply 9%. In the previous example, we applied 7%. Try to apply 9%. It is, you will get 2,112. In the previous discount, we get 2,541. So it's more decrease in the by using 9%. But if you are using 2%, we will get 4,000. So it increase. Okay, look at this chart. In this chart, it doesn't matter how much we are. In this, we are using 0 rates. So because we are using 0 rates, the future value is the present value. It doesn't matter how many years you invest. So this is 0, so the n, it doesn't matter, so we will get the future value divided by 1. So the present value is equal to the future value, doesn't matter the number of years that you invest. But look at the green one. The green one, we are using 2 or 3 years. It is little below the 100 because we are using 2%. But when we are using 5%, 10%, it decreases more than the 2% or the 5%. Okay, let's take this example here. Solving the present value of a future value cash flow. Your firm has just sold a piece of property, $500,000, but under the sales agreement, it won't receive the $500,000 until 10 years from today. What is the present value of $100,000 to be received 10 years from today if the discount rate is 6% annually? So what it means? It means you agreed to sell your house by $500,000, but you will receive it after 10 years. What is the present value of this value of this house? Okay, so very simple. You will receive $500,000, then divided by 1 plus I is 6% over 10 years. Okay, so you do the same. 500,000 divided by 1.06 power 10. Then it's equal 279, 197. So it is 279,197. Okay?
Yes.
Okay. So this is the result. Okay, so check yourself. What is the present value of $100,000 to be received at the end of 25 years given a 5% discount rate? Similar to this, but just replace 500,000 by 100,000.
And I
Then the interest is 5% and N is 25. How much? 29. Then the answer is 29,530. Okay, excellent. Now, this one. Let's look back to the present value equation here, or the future value. Again, future value is equal to present value 1 plus I the power n. In the normal case, I give you the present value and I and n, and then calculate the future value. In some cases, okay, the present value is present, but maybe I is not present or n is not present. So I'm asking you how long it takes from you to invest the future value to invest the present value to give this future value. For instance, the present value is 20,000 and the future value is 30,000, for instance. How long it takes to invest $20,000 to be $30,000 if you consider that the interest rate is 6%. So we're asking about n. We're asking about n. Or we can do it in different way. What is the interest rate if we want to invest $20,000 to be $30,000 and the periods that we invest our investment for 5 years? So what is the interest rate? So now we're asking about the interest rate. Go to this question and try to answer this question. Let's assume that the Toyota Corporation has guaranteed that the price of a new Prius will always be $20,000. And you'd like to buy one, but currently have only 7,752. How many years will it take for you initial investment of 7,752 to grow to $20,000 if it is invested so that it earns 9% compounded annually? Okay, so let's see. Okay, so $20,000 is the future value. Is $20,000, and you'd like to buy one, but currently have only 7. So the present value is 7,752. How many years? So we're asking about how many years. We don't know. How many years will take for your initial investment to grow 20,000? If it is investment at I is 9%. So the equation is future value is equal to the present value 1 plus I power n. So we know the future value is 20,000. We know the present value is 7,752. And we know I, 1 plus I is 9%. And we don't know n. We don't know n. So what you can do then?
بنقسم ل 20,000 على 7,700.
Okay, just hold on. What we can do, just one by one.
بنقسم ال 20,000 على
Okay.
7,700.
20,000 divided by 7,752 is equal
واحد
1 plus 9% power n.
نزل الآن
Now, so n is equal.
لوك الآن
Now n is equal what? Yes. So n is log 20,000 divided by log 109%. Okay?
ماينس عشان السواد.
Sorry?
حط ماينس لوج ال 1.09 الدكتور هلا بدي اقسم هدول على هذا يطلع لي 2.6
أشهد.
لما اقسم 2.6
جربوا هيك. Try this.
بدي اقسم ال 20,000 على 7,000
Yes, yeah.
2.6
Log 20,000 divided by 7,752. Yes. Yeah. Yeah, do it like this. It is 11. Okay, so now is the log. Okay, divided by log 1.49. So the answer is 10.99. It is around 11 years. So the answer is 11 years. Okay? Very simple here, because this is to the power n. If you want to multiply by the power n, just do the log. Okay, just do the log. The log is equal. The n is equal. The log of 20,000 divided by this, and divided by the log 109. يعني عشان نضيع الان اللي فوق، لانه ان هنا اكس تعتبر، فبنجيب اللوج تبع هذه واللوج تبع هذه. اوكي؟ لانه هنا بدنا نعتبر يعني look at here. فهان جبنا بتصير 20,000 divided by 1.09 باور اوكي 1.09 فبتصير هنا x باور n. هنا حتصير x باور n. x باور n. عشان نجيب x فلازم نقول x is equal the log of 20,000 7,752 divided by the log of 109. فعشان نجيب x. X here in number of years. So the x here is number of years. Okay, let's take another example. ها؟ نشوف. إذا الانترست مش موجودة ممكن تكون أسهل لا؟ ولا أصعب؟ أصعب؟ طيب. See the answer is okay, take this. How many years will it take for 10,000 to grow to 200,000 given a 15% compound growth rate? بسرعة هذا السؤال. ال 10,000 عشان تصير 200,000 و15% عندنا الانترست ريت. Okay. So the future value is 200,000. The present value is 10,000. N, we don't know N. So N is X. I is 15%. Okay. Now, the future value is 200,000 is equal 10,000 1.15 or 0.15 power x. We don't know x. So 20,000, 10,000 it takes by 10,000. So we have 2. 2 is equal 1.5, 1.15 power x. So we want to calculate x. So the x is log 2 divided by log 1.15. So log 2 divided by log
لو بال20 مش 2
20. Okay. So here 20 divided by log 20 divided by log 1.15. So it is 21.43. 21.43 years. Okay. So 21.43 years. Okay. The last one. The role of 72. What it means, very simple. It means if you have $10,000, how long it takes to double this amount, to double this investment. To double it means to be 20,000. If you have 50,000, how long it takes to be 100,000. If you have 25,000, how long it takes to double to be 50,000. Just what should you do is just divide it 72 by the interest rate. So 72 divided by the interest rate. If you don't believe this, just do it in a different way, and you will get the same results. Example 5.7, using rule of 72, determine how long it will take to double your investment of $10,000 if you are able to generate an annual return of 9%. 72 divided by 9, just ignore the percentage. 72 divided by 9, so it's 8 years. Do it in a different way, and you will get $20,000. Okay? We will stop here, and we solve the problem if we don't know n. In the next meeting, we will solve the problem if we don't know I. Okay? Any question? يلا يعطيكم العافية وإن شاء الله تنبسطوا في الامتحانات.